Hello, this is Faith with beyondabc.blogspot.com. That is BEEYOND And today we have a mental math moment. Our objective is that your student will be able to mentally find sums when one of the addends is either 8 or 9. Next, we're going to discuss prerequisites. Your child should know their addition facts to 10. And it's pretty common that we use manipulatives to teach addition facts. And I would just say do them over and over again until your child knows those facts. Before you even start doing numbers to 10, though, make sure they know there are 5 ands. 5 and 1 is 6. 5 and 2 is 7. 5 and 4 is 9. 5 and 5 is 10. Have them do that first. And you could use different color Lego blocks or Unifix cubes, whatever. Just stack 5 of one color and then you add a 1 of a new color and you have 6. 5 plus 1 is 6. That's the easy way to do it. And I'm going to show you another manipulative a little bit later. But do that first, and then after you do that and your child remembers those facts, make sure your child knows those sum facts up to 10. So you're going to do 5 and 2 is 7, but then after that, you're going to do 4 and 3 is 7. Okay? So that's that. And next, your child needs to understand place value. And I will put links to resources as we go along. But for example, they should know that 36 is 3 tens and 6 ones. 78 is 7 tens and 8 ones. Likewise, they should know 45 plus 10 is 55. Or 78 plus 20 is 98. Even more so, they should know that 95 plus 10 is 105. Okay? So, just, again, I'll put links to resources if you need them. Lastly, your child should be able to use mental math to get to sums up to 20. I only put 18 here because what I want to deal with in this section is sums of addends which are less than 10, 10 and less. So you're looking at, say, 9 plus 9 is 18. And to get to 19, one of those addends has to be a 10. So that to me seems to be more of a function of place value. So I didn't include that. And if your child doesn't have any of these strategies, these mental math strategies, we'll talk about a few. So you could just learn those really quickly, teach them to your child, do those over and over again, and then go on to the next part of the video at a later date or something. Okay, let's talk about what mental math is not. Mental math is not memorization. And while memorization has its place, once your child gets about 3, 4, maybe sooner for some children, maybe longer or later for others, but your child should be figuring out why things are the way they are. And you just want to guide them in that process. For example, if you want to teach your child to count by twos, don't just teach them 2, 4, 6, 8. I mean, of course, they'll remember it if you do it every day, but you can do it in a way that adds meaning. Let's suppose you have an abacus, right? And you have your child pull 2 beads down and count. How many is that? 2. Have them write down 2. If they can't write yet, you can write it for them, as long as they can recognize that that symbol is the same thing as what's on the abacus. All right, and then they pull 2 down, they have 4, right, and so on, they get 6, right? They've done that, and they realize that when they're counting by twos, each time they're adding 2 to the previous number, right? Aside from that, they're practicing adding. Aside from that, they've written it down. You can ask them if they see a pattern. If they see a pattern, great. If not, you can point it out to them that they're skip counting, right? So you go from 2, skip 3, go to 4. They'll learn that. So you practice skip counting every day. And then just as fast almost as memorization, they will learn or remember to skip count. And if they never remember, it's okay. They know how to count by twos. They know how to get to the answer. And now they have a skill that they can use from they could count by twos from two, but they also could count by two from any number. You could start them from one and have them count the odd numbers because they know a skill that they can apply at any time. So memorization has its place, but let's add experiences that will make our children or help our children to develop stronger, more fluid number sense. Okay, mental math is also not using your fingers and other manipulatives to solve problems. Yeah, manipulatives, they are great. We love them. But you want to use your manipulative toward mastery, not as a crutch. If it's, if you can add three-digit numbers and you're using your fingers, you can get the answer that way. But to me, I think that your fingers have become a crutch. And for that reason, I don't allow my child to use her fingers at all. If she has to use her fingers, then we need to review because, in my opinion, there's a hiccup somewhere in her number sense in that development if she needs her fingers, right? So, when we choose our manipulatives, we want to choose them wisely, right? Um, so, I'm going to show you some that I like to use, or two actually. They're kind of like the same thing. But this is the AL Abacus. You can get it from rightstartmath.com. This is an interactive version. I don't think it's all that interactive, but the AL Abacus is an actual abacus that starts around $15. They also have an iTunes app version. At the time I bought it, it was $2, and I think it's a really good manipulative to use. If you notice that the beads are color coded, and this is one of the few abaci that I've seen that not only color codes across the strings, but they color code the tens in the sense that the first five tens start off with blue beads and the last five tens start off with the yellow beads, right? So this is the AL Abacus, and it is available on iTunes. I'm not sure about Google at all. Okay, so this is a number rack, and a number rack is actually free. It's from the Math Learning Center, and by default, it looks like this. It has one strand of 10 beads, and it looks like a Renikin. So if you want to, you could just make a Renikin if you want to do it for cheap. But this virtual version is free. They also have an iTunes version, which is also free. And look for Google. They may have that as well. Okay, so but you can take it to 10 Bs like a more traditional abacus, right? So let me just see if your child needed to, if you want your child to experience seven and you ask them to give you 7 Bs, right? At first it's going to take forever, but eventually they'll do this, right? Because they'll know that 7 is 5 and 2. And the brain is just going to pick that up. If it doesn't seem like it's picking it up, it's fine. You can support it. But 7 is 5 and 2. And your brain is subconsciously picking up more than that because this whole thing is 10. You know that. So you're leaving 3 behind. So you're getting 7 plus 3, 10 minus 3, 10 minus 7, 5 plus 2, 7 minus 5, 7 minus 2, all those things. Your brain is automatically grouping the numbers, or it should automatically group the numbers by using a manipulative such as this. So that's why I like these. And remember to use your manipulatives not as a crutch, but toward mastery. Before we go into the strategies, I just wanted to give a quick warning. We are not trying to make math zombies, right? Mental math involves using your own brain, your own way of thinking to solve problems. There usually is more than one way to a solution, right? So we really want to celebrate our children's individuality. And while we are presenting specific strategies, and we may even require at times that they only use a specific strategy to that solution, for the purpose of teaching, we may do that. But ultimately, the child should choose which strategy works best for them. The child should be allowed to come up with their own strategies as well. The child should be allowed to modify any strategy so that it fits them. So, no zombies here. Let your child lead the way. Even if you have to restrict what they're doing for a while for the purpose of teaching, let them lead the way in your learning. Okay, now we're ready for strategies. And before we begin adding eights and nines, let's go back to prerequisite number 3 and make sure that our children are able to use their math strategies to find sums up to and including 20. For the first few of these, we're only going to deal with addends that are 10 or less. And the very first strategy is to view each addend as a sum of 5 plus another number. So we have our problem here, which is 7 plus 6. And again, we want each addend, the 7 and the 6, to be viewed as 5 plus something else. So this 7 here, we want to see it as 5 plus another number. And of course, 7 is 5 plus 2, and 6 is 5 plus 1. And then we want a chunk. Okay, it's already there. We want to chunk, take the 5s and chunk them together. 5 from the 7 and 5 from the 6. Put those together, and then we're going to put the 2 that's left over and the 1 that's left over together. So now we have 5 plus 5 plus 2 plus 1, and of course 5 plus 5 is 10, and 2 plus 1 is 3, and because we are place value wizards by now, we know that 10 plus 3 is 13. And just briefly, I'll show you a way to do it on the abacus. There's no law. You can do it however you choose. So let's say we have 7 here and 6 here. And you can separate the 5s. So you can just visually see that that's 10 and that's 3. So let's go to another strategy. And that is to make one of the addends into a 10. So again, we have 6 plus 7, and it's a little bit different than before because we've reversed the addends. But you can go ahead and show your child that, the commutative property, that no matter the order that they're the same. You don't have to do a lot of teaching. You can let them experience it. Write 5 plus 1. Let them write down their answer. Then write 1 plus 5. And then ask them what do they think the answer will be. Just get the juices flowing, and then let them find the answer, and it'll be solidified for life. So anyway, we have 6 plus 7, and instead of making this 6 into 5 plus another number, we're going to make this 7 into a 10. Now, the reason I chose this 7 is because it's closer to 10. I don't have to. I could very well choose to do the 6, but this might be a little bit easier for me. So present both ways to your child and explain why you would choose this one, but again, let them make their own decision. And of course, 7 is 3 away from 10. So what we're going to do is take 3 from the 6 and give it to the 7. So I have 6 minus 3 here. I'm taking it away from here. 7 plus 3 here and giving it to that 7. So our new problem becomes 3 plus 10 is 13. Okay, and then I can show you this as well. So we start off with the 6 up top, I guess. And the 7 here. And what did we do? Okay, we added 3. So we're going to take 3 from here. Put it there. And you have your 13. Now, with both of these, you're not going to write them down. I mean, you could choose to, but the idea is that your child understands it. Because writing it down could be a little more confusing in some cases, but you just want your child to practice it and to understand mentally how to do it. We want these to be mental functions more so than writing down 5 plus 2, 5 plus 1. You want them to think in this regard. Okay, now we're going to deal with problems with addends that are greater than 10, at least one addend greater than 10. So the first of these strategies would be to separate the tens from the ones. And I think this is kind of something we already do. So very simply, let me show you the first problem, which is 12 plus 6. So only one of these is above 10. So we're going to separate the tens. So the one tens, which is 10, and the two ones. So the new problem becomes 10 plus 2, which we know is 12, plus this 6. And then we're going to regroup it again. So this 10 is out here by itself. We're going to go here first, 2 plus 6, which we know is 8. And then we have that 10 from there. 10 plus 8 is 18. It seems like a lot of steps, but let me show you what it would really be like over here. Oh, let me get a highlighter. So what we would basically do is just add the ones. Add the tens in our head. So that's 2, and then add the ones. 2 plus 7 is 9. So the answer is 29. Because we've separated the ones from the tens. So the tens, 10 plus 10 is 20. The ones, 2 plus 7 is 9. Same thing here. Right. So we have 58. That's our answer. And we got that again by adding the tens, the numbers in the tens column, and then adding the numbers in the ones column. Now I would like to show you the next strategy, which is make it into 10. It's the same as before, right? 6 plus 12, we want to make that 12 into a 10. Because it's closer, it's the closest to 10, the number 10, we're going to subtract 2. So what we do is take 2 away from the 12 and give it to the 6. So our problem becomes 6 plus 2 plus 12 minus 2. And that's 8 plus 10, which we know is 18. So how does that look over here? It's kind of the same thing. Like, let's start here with the 17. We can make that to 20, right? It's 3 away. So we're going to add 3 here, subtract 3 from there. So this is a 9 plus 20, 29. I'll show you this one. Make it into a 10. So this is 3 away from 50. So you have 50 and take 3 from here. 50 plus 53 is 103. Okay, I wanted to show you one more thing, how this could be done in a different way. Okay, the other way to do this would just be to, let's say, keep the first number, 24, plus, and then separate the tens and the ones from the second number, plus 30, plus 5. Uh-oh. So you'll have 54 plus 5, which is 59. But would you think of it that way? Probably not. You would automatically go 54 plus 5. You automatically see this 24 plus 30, 54 plus 5. That's the answer, 59. Okay, so this is the part that you've all been waiting for, or you probably really haven't been waiting for, but this is the reason why I even made this video. This was supposed to be the mental math moment. Instead, you got like a lot of other mental math moments, and I hope all that other information was helpful. But this is adding eights or nines, okay? So we start off with the 24 here, and there's the 8. And guess what the technique is? We've already seen this strategy twice. This will be the third time. It's no different this time than any other time. You're going to make that 8 into a 10, right? 8 is 2 away from 10. So you're going to add 2 here and subtract 2 from there. So add 2 to the 8, subtract 2 from 24. You get 22 after you subtract the 2 from 24, and you get an 8. You'll get a 10 after adding 2 to the 8. So 22 plus 10 is 32. And that's all it is. So I'll show you this really briefly. This is a Flash app that I made. It's supposed to approximate a place value flip chart. I looked all over the internet for a virtual one. I could not find one, and I made my own flip chart, but I couldn't put my hands on it. You know, if you know anything about me, I'm in transition, so I'm not in my house yet, and I could not put my hands on that flip chart. So I made this one with Flash. So if you have a Flash enabled device, you can use this. So the number is 24. You just put that in, the one that you start with. And here's the shortcut. You're going to add 10, but you really want to add 8. So by adding 10, you've added too many. So you're going to add 10 and then take away 2. So with adding 10, we're just going to change this 10's place value here. Take away 2 there. So there's my answer, 32. Let's move this up 1. Let's say 33 plus 8. Again, you add 10, take away 2. Okay, same thing. Add 10. Uh-oh. Take away 2. The problem here, though, is 51 minus 2 is 49. So I thought about changing it so that when you're at a 0 and you hit that back button on the ones spot, it'll change the tens too. But this way, your child has to know. Your child has to see how it goes. So I don't know if I'll do that. I don't know. I may make some changes. But for now, your child has to notice that 51 minus 2 was 49. Okay? Which I kind of like. I want to keep them on their toes, especially when it comes to place value. All right, so one more. We're going to add 10, take away 2. So what was it? 49 plus 8 is 57. Now with 9, this might be a little bit easier adding 9. 16 plus 9 is the problem. Of course, 9 is 1 away from 10. So you're going to subtract 1 from the 16 and give that 1 to that 9. You get 15 plus 10 equals 25. So we'll just start from here. 57 plus 9, you're going to add 1, take away 1. And it really doesn't matter if you take away the ones first or add to the tens first. So let's go 66 plus 9, take away 1. Add 1 to the 10 spot is 75. And one more, add 1 to the 10 spot, take away 1 from the 1 spot, and 75 plus 9 is 84. And you can keep going and keep going and keep going. But before you even get to this place chart, practice these strategies over and over and over again. Use your abacus if needed. Just practice them and then be able to do them in your head. And then come to the place chart and see if you can find that. See if you can find that pattern. And then if they don't, after they've practiced, then you can tell them. But you want it to mean, you want them to understand why. And you can keep going, in your head. 84 plus 9 is 93. 93 plus 9 is 102. 102 plus 9 is 111. 111 plus 9 is 120. That's easy. 120 plus 9 is 129. That's easy too. 129 plus 9 is 138. And you can keep going and going and going. And you have no problem because you have a strategy to figure it out. And you didn't have to carry no ones. You didn't have to add the ones placed first. It seems like more steps initially, but when you develop your number sense, things go a lot quicker. Okay, so thank you for paying attention. Thank you for watching the video or videos. I haven't decided if I'm gonna put up like a bunch of videos or just one video, but either way, thank you. I know that this was long. It was not my intent to do all of this, but I hope that the information was helpful. And go check out beyondabc.blogspot.com. That's BEEYOND ABC.blogspot.com.